Greetings everyone. My name is Konala Venkatarama Manohar. I'm currently pursuing my BTech at Lovely Professional University. Today I'm going to explain like stack implementation using linked list. So before going into the topic, let's understand the concept of linked list. So linked list is a linear data structure. It is dynamic in nature. So in simple words, we can tell that a linked list can be like a chain of connected nodes as we see here. So what is a node? A node like let's take a node is a box which contains data and address of next node. So this is the diagrammatic representation of how does a linked list look like. So we can see here, like this node, the first node has the data and the address to the next node. So a first node in a linked list is called as a head, and the last node in the linked list is called as a tail, and the tail does not have any arrow pointing to the next node because there is no one, because as it is the one. So like there will be a null value in place of an address. And why do we have to use only linked list? Like we can use arrays also, right? So how do they both differ? Like unlike arrays, linked list can expand or mean contract, we can say that easily. Like I can just add another node here, another data here. All of a sudden I just have to change the address to this node and then the address of this node to this one, so that a new data is added without any without any difficulty. But in an array we have to insert or delete, like it's like a process. But in linked list it's quite easy. uh, this is the dynamic nature of the linked list, and here we can say that I can just add another node here, or I can just delete this node. I can just delete this node, so which makes it useful over arrays. So in conclusion, a linked list is like a dynamic chain of boxes, as we can see on the screen here, like this, each holding the data and pointing to the next one. Uh, so now let's go for the concept of stack. So what is a stack in a data structure? A stack is a versatile concept in DSA. Imagine, like let's take one example here. How does a stack look like? So let's take this as a container or something like that, in which there are various plates or something. So if you are adding another one, so this is going to be on top of the previous one. So like you add another data on top of the data, and we can remove the topmost data, means the last data that is added. So that is this data right here. So this can be removed easily. So we can say we can take uh, last in first out principle. And there are some key operations in stack, such as push and pop. Push and pop. So we can just tell by the name that push is an operation that adds an element of the on top of stack. Like if So as the last data that is added, this the data here that will be that it is going to be removed first. So let's take for our convenience as 1 and 2. So if you use push operation, then the element 2 is going to be added on top of the data 1, and if you use pop, then the data 2 is going to be removed first. So this explains why stack follows last in first out. We can take some examples like a stack of plates, a stack of some things like the last plate that we are going to be keeping on top of the other plates is the plate that we are going to take out first, right? So like where do we use stack in programming? We can like in the function call stack, like a stack is often used to keep the track of function calls. Like when a function is called, it's like pushing it into the stack where, and when it's done, it's popped off like this. And in the expression evaluation, as well as in converting infix expressions to postfix. So that's all about stack. So in contrary, we can tell that a stack is a versatile and efficient data structure that follows the last in and first out principle, making it very useful in many programming scenarios like managing function calls to tracking history or undoing actions. So this is all about stack. Now let's implement stack using linked list. So as I said earlier, a linked list has a node, right? So let's start with creating a class of node. So this is a class of node. So let's initialize it with a constructor. So the node class has two attributes for now. That is that is the data, and the next node and the next attribute. So that the data attribute simply means that the actual data of the node, and the next attribute references to the next node in the linked list. So that is self dot data is equals to data, and is equals to none, as we are taking an empty linked list for now. So that means, like as we discussed in the tail part, that there will be, if there is only like, if that stack is empty, that means it has no address of the next one, so we are taking the next as none. So we have created a class for node. Now let's create a class for linked list. This is a linked list class. Now let's initialize it. So linked list has an head, right? So the attribute of this class would be head. So the head part is now simply none, as as we are taking an empty linked list. So now let's apply the operations. Let's start with the push operation, push function. So as I said earlier, push is a function in the stack data structure. Means we can append the data. Uh, we can append the data to the stack. So let's create a new node which is given data by us. So if the stack is empty, self self dot. Yeah. So if the stack is empty, suppose we took an empty stack. So and if you want to take an empty stack, so even that is fine. So if you are taking an empty one, so then so as we are entering data, that data is connected to the head node. Okay, or else if there is an data already existing, next is not none. So, I mean, else if the head is not none, like we are going to set a pointer to the, I mean, to the current node, and then we will be reaching wherever we want until the head node is not none. So that means the node here is equals to node dot next. Means we are moving on to the next node. So the node dot next here will be is equals to new. So we are setting the next node of the current node here to the new node. So we are setting the next node of the current node to the new node. So means uh, the current node which we are having, we are connecting it into the new node here. So that's all about the function push. So let's go with the function pop. So pop function, yeah. So pop function in the stack is to remove, sorry, is to remove or delete element in the stack. So if self dot head is equals to none, means if the stack is empty, so that means there is nothing to re return, right? So we are going to print it as that, or else, I mean, if there is data existing, else pre, let's take pre here. So like here pre is equals to none means that we are setting a pointer to the monitor to monitor the previous node in the stack. Like we are setting this pre here to, like, to look at the previous node in the stack. So here node is equals to self dot HEAD. So we are setting uh, a head to a pointer to the current node. That's the head node. Okay. So now while node dot next is not none, the one which we set earlier will be set to the node. So this is the node here, that is the previous node is going to be the current node. Uh, so that means the node is equals to node dot next. So here we are moving on to the node. We have to connect the next node to this node, right? So we are using node is equals to node dot next, like moving on to the next node. So pre dot next new. So like we are removing the last node here by setting the previous nodes next to none. So like how are we removing the last node here? So let's have a look at that again. That's the pre dot next is equals to none. So basically it means like we are removing the last node by setting the previous nodes next to none. So that means it makes it the last node. So when we are using the pop, it will be removed. So that is all about the peak function. Uh, and sorry for that, I forgot to discuss about the peak function earlier. So peak means like like peeking into a park display. Like peak is a function in stack, we can say. Like it's a function in stack to view or show the data, like the topmost data in the stack. So if self dot, okay, if the head is none, if the, I mean, if the stack is empty, it is going to return the stack is okay. We used that already. Let's go with another. So else means what if it's not empty? Then the node is equals to node dot next. That is, and then so that means if the sorry for that, if the stack is empty, then it's going to return that the stack is empty. Or else, like if it is not empty, then node is equals to self dot, okay, sorry, I might have done a mistake here. That is self, right? Sorry guys, that is self dot head. We are setting it to the current node. So like while the node next is not none, so node is equals to node dot next. So now we are moving on to the new node here. So this is going to like the node dot data. After this, the node dot data is going to print the topmost data in the stack. So to print that, we have to use the print function. Print. We can go with the top most data element is, that is nothing but node dot data. Okay, so now we have completed like the pop, the push, and we are also done with def. So now let's go with another. Let's count like how many elements or items are there in a stack, right? So now for our convenience, let's initialize it with a counter or something like that, so that we can count. C is equals to 0. So if self dot head is none, means if the stack is empty, there is nothing to count. So let's go with nothing to count. Or else if the stack is not empty, else let's initialize the node here. Let's give the node as self dotted as we did in the previous functions, and next not none. So here, while the node dot next is not none, that means there is the other node, right? So that means we have to increment the counter here, so that it's going to keep count of, it's going to keep track of the count. So that means C plus is equals to 0. So, and then we have to move to the next node, right? So that is node is equals to node dot next. So, uh, yeah, so that's going to, if we come out of the loop, then it will print the length of the stack. Uh, Length is C1. So now we have done like four functions, that is the pop, the peak, and the count. So now we can add something as a menu drive, so that like whenever we choose something like an option, we can just it's going to implement that function that we are going to choose. So name is equals to, yeah. So here the this is like a common idiom used in the Python modules to like the part if name is equals to main here. This part, it ensures that the code inside this block gets executed. Okay, and like it's going to like when the module is run as the main program, that means the whole part that we had, and when it is not imported. So like this creates some new instant of the linked list class. The so the while okay, now let's continue here. So now let's create a linked list here. Let it be ll is equals to list. So we are going to keep it as while true. So like why are we using while true here? So like while true here starts an infinite loop. The code inside the loop will continue to execute indefinitely until the user wants to stop the code. Okay. So now let's print out the options. Select a number. Fashion one dot. So our first function is push. So let's go with push here. And then the second one is pop. And then the third one is peak length. So as I said, while true, like it runs infinitely, right? So let's add another option here, that is exit. Like if the user wants to exit, then then he has this desire so that he can exit the loop. So now let's give an input. Let it be something called an s is equals to an input number. Okay. So now uh, if s is equals to 1, then dot, okay, if is, yeah, sorry, it's push, right? Yeah, int the input. So like, so yeah, So initially the user is going to give an input s here. So if that s is equals to 1, then it's going to then that is the push operation right here. So the linked list that we have created here is going to push, I mean, the element that we have taken previously into the stack here. So that is this. Now let's go and then now let's go with the pop, that is elif u, I mean, s is equals to 2. So that's going to print ll dot pop, right? That is going to be print ll dot pop. So that's going to pop the data from the stack. So now let's go with uh, if the user user sorry, 3. So that is peak, right? So that is uh, ll dot, if the user gives an input of 4, so that is the length of the stack. So we have did that also. So that is dot count. It's going to give the number of items in the stack. And last, that is if elif sorry, that is elif if s is equals to 5, right? So that means the user wants to exit. So I want to exit. Okay, now this is the whole coding part, and I guess we didn't miss anything. So while to to stop this loop, we have to use an break function, or else the loop. As we can see here, we have used like a push, a pop, pick, and count. And that's it. I want to thank my teacher and my mentor Jasa for creating me this opportunity, and my DSSO Pramod sir on helping me with this video. Thank you everyone.